Histogram. Horizontal axis.
Horizontal axis is your x-axis. It runs this way from left to right like the horizon. Horizontal, horizon. That's your x-axis. Up and down is vertical axis. That's your y-axis.
Vertical axis. Bar. How do you make and interpret a histogram? Think about this question during the lesson. In a telephone survey, a radio station recorded the ages of 25 callers. The radio station wanted to represent and display the results of the phone survey. What are some different ways to represent and display data?
Okay, we've learned about some of the different ways of organizing data, but remember yesterday we were talking about line graphs, and we said line graphs are best used when something takes place over time. Does this right here take place over time? No, a line graph would not be ideal to use for this. We said line graphs are good when it's something that takes place over time, like for a week you track your pace running a mile, or at every hour you track the temperature, or for 5 years you track your height growth, okay? That is something that takes place over time. That's when a line graph is ideal. But this here is nothing that takes place over time. This is the ages and the frequencies of calls, okay? So from 0 to 19-year-olds, 6. From 20 to 39-year-olds, 12. From 40 to 59-year-olds, 5. From 60 to 79-year-olds, 2.
Examples of some different ways to represent and display data are bar graph, circle graph, stem and leaf plot, line graph, histogram.
Okay, all of these, they're just saying all of the ones that we've learned about so far, which are all means of organizing data.
What is a histogram? A histogram is a bar graph with no space between the bars. Equal intervals are shown on the horizontal axis.
Okay, so you notice there is no space here, no space here, no space here. With the histogram, you make the bars sit right next to each other. And the intervals, which are right here, X, Y, your intervals go on your x-axis, your horizontal axis. So this is going to be the 0 to 19. This is going to be the 20 to 39. This is going to be the 40 to 45. This is going to be the 60 to 79. It's different from a bar graph because a bar graph has spaces in between. They're not touching. And a bar graph has a set value underneath it. 1, 2, 3, 4. Or 2, 4, 6, 8. It's not a range of numbers.
What does it mean that equal intervals are shown on the horizontal axis? Instead of a single number, each bar represents an interval, such as 0 to 19. What will the intervals be in this example? The intervals are age ranges, which are 0 to 19, 20 to 39, 40 to 59, and 60 to 79.
Notice that the next one starts right where this one left off. You don't skip any numbers. This age interval was 0 to 19, so this one starts with 20. It ends in 39, so this one starts with 40.
Why do the age ranges go from 0 to 19 and 20 to 39 and not 0 to 20 and 20 to 40? The age ranges cannot contain information from another group.
Okay, so what he's saying is you can't have 0 to 20 and then start here with 20 to 40. Okay, your age ranges cannot overlap. So we can't have 0 to 20, 20 to 40, 40 to 80, 80 to 100, because then we would have 20s here, 40s here, 80s here. We would have numbers overlapping. Nothing overlaps.
How do you construct a histogram? Let's find out. Start with a 4 by 6 grid.
Oops, sorry.
Next, mark the
Back it up.
Start with a 4 by 6 grid. List the age intervals from the chart along the horizontal axis. Label the axis. Next, mark the scale along the vertical axis. Choose an interval. Label the axis.
Okay, we see that our numbers range from 2 to 12, 2 being the smallest, 12 being the largest, so they decided to go by twos. You always start with 0. We learned about that a while back ago. You always start with 0. They decided to go by twos.
List the greatest and least numbers in the survey results. What are the greatest and least numbers? The greatest and least numbers in the survey results are 12, 2. Why do you list the greatest and least numbers when marking the scale?
Sorry, not sure why it's there.
You mark these numbers to ensure that the scale is tall enough to include all of the data.
Okay, make sure that your largest number is included here. Make sure that your smallest number is included in your scale, okay? They're just saying that, I think, to make sure you don't stop at 10 whenever you have numbers that need to go up to 20. I'm sorry, to 12.
Graph the data by drawing bars of the correct height. Then title the graph. Now interpret the graph.
That means understanding what it's saying by looking at it.
Compare the data of the 20 to 39 age group to the data of the 0 to 19 age group.
Okay, look at this. For calls made, we have 20 to 39 is the highest. The next highest is 0 to 19-year-olds. Makes sense, you think? Probably. Teenagers are on the phone just about as much. Probably now it would be more, okay, as that age group of adults. Senior citizens, the older group. Well, Devin, hope your grandma's not listening to this. No, I'm joking. But you're right. They probably, for a lot of reasons, may not use the phone as much.
Twice as many callers were in the 20 to 39 age group as in the 0 to 19 age group.
Yeah, they're sometimes afraid they're going to mess something up, I think.
Which age group had the most callers in the phone survey?
20 to 39.
Most callers were in the 20 to 39 age group. Which age group had the least number of callers in the phone survey?
60 to 79.
The group with the least number of callers was the 60 to 79 age group.
Also, look, this was a radio survey. We think teenagers probably listen to the radio quite a bit. We think that this age group, 20 to 39, probably does quite a bit. But senior citizens, probably not as much.
They might accidentally call the wrong number.
Be nice.
From the histogram, can you tell if all 12 of the students who fell in the 20 to 39 range were the same age?
Can you tell what age they were? The people from the 20 to 39 range? No, we don't know. They could have been, some of them 21, some of them 20, some of them 27, some of them 38. We don't know. We just know their age fell somewhere in there.
No, you cannot tell if all 12 of the students in the 20 to 39 range were the same age. The data shows only a frequency count. After working through this example, you now know how to make and interpret a histogram.